Hey guys, and welcome back to the Third Ferg Show. All right, so the last video that we did, what we actually did is we took a look at average velocity or constant velocity. And so we wrote a formula that looked like this: change in displacement over a change in time, and that's basically all there is to working average velocity or even constant velocity problems. It's really as simple as usually nothing but, x over t is what we can kind of simplify the equation down to. And it's not exactly a distance over time, because remember, x actually means displacement. Well, as we get started with this today, I'm going to go through all the equations, and I may at some point go back in my old series of videos. Actually got where I derive all the kinematic equations. We're just going to kind of present them in this video. So here's what we've got going on today. We've got a situation where an object starts off at one velocity and then actually changes that velocity. So it's not a constant velocity. So we've got some v sub 0, and we reach some final velocity v. And then right off the bat, you may look at this and be like, what's v sub 0? What's v? So check it out. Different strokes for different folks, I think, is the old expression. Some teachers in textbooks use velocity initial and velocity final. I use v sub 0 and v. And so that literally means velocity at time of 0, which is the exact same thing as velocity initial. So when I write just a v for me throughout the course, that means v final. And I can go ahead and tell you, some teachers might actually use this terminology, v and v prime. And if your teacher uses that, just the v is your velocity initial and v prime is your velocity final. So I say that because there are, and you might even come back and say, I've got a guy using something completely different, or a woman using something completely different. So anyway, let's take a look. We've got two velocities. So you start at one speed, and you either speed up or slow down. And that speeding up or slowing down, that's what we call acceleration A. And its unit is meter per second square. It's what we'll use it for. If you were in like our American units, you might say like feet per second square. Now, I'm also going to do this. I'm going to say position and time. And what's cool about working these problems, it's really as simple as this. In order to work an acceleration problem, you need 3 of these 5 variables given. So now let's do something. Let's take a look at every equation that you might possibly need in order to solve one of these problems. Well, believe it or not, you'll still use this average velocity equation, but you need to take special note. People always want to use either this velocity or this velocity and plug it in for average velocity. Notice this is not the same. Average velocity is just that. You've got 2 velocities. So an average velocity is nothing but those 2 velocities added together and divided by 2. So what's cool is, let's say, for example, you were doing a problem and let's just say it started at 0 meters per second, sped up to 10 meters per second. Your average velocity would be 0 plus 10 divided by 2, so it's 5 meters per second. So that's a very handy trick to kind of use when you're working problems. So keep that in mind, that it's very easy to find an average velocity sometimes. All right, let's go through. Here's your other kinematic equations. We've got this one. This is basically your general acceleration equation. All it is solve for velocity. And so I usually refer to this as like the first kinematic equation. So if you see me say, use the first equation, I'm referring to this one. And all it is, it's a play off the definition of acceleration. Acceleration is nothing but a change in velocity over a change in time. And so there is your basic definition of what acceleration is. So if we solve this out as velocity final minus velocity initial, it actually just turns into this equation. And I've got a separate video where I derive all the kinematic equations. This one, we're just presenting them. So I usually don't ever write this equation. I usually just go straight for this one over here. All right, so Now we can come back and do number 2, my second kinematic equation. I usually write this: change in position or change in displacement, or just displacement, is equal to your velocity initial times time plus 1/2 the acceleration times the time squared. And again, we can derive these if we wanted to. And then the third kinematic equation, which some people refer to as the timeless equation, sounds kind of nostalgic when you say it that way, is equal to velocity final square equals velocity initial square plus 2a delta x. And I'll be the first one to tell you, usually when I'm working these problems, I usually don't write the delta x. All delta x is x final minus x initial. So you're going to see me as we start doing these problems. I'm not going to write delta x. I'm just too lazy, to be honest. Maybe that should be the name of my channel, the lazy physicist person. Anyway, usually for me, x initial, I just make that my 0 for every problem. Well, if that's my 0, then all we've got is just an x final. So what you're going to see me write is usually just x, which is my x final. So I'll go ahead and tell you, if you're taking a basic physics course, about the only time you're going to actually need the x final minus x initial is if you're doing a problem and it's what I refer to as a chase problem. And I'll actually work a couple of those. For example, you've got one car sitting still and another car is coming up behind it, and it passes by and they chase each other and catch the other one. In this problem, you'll actually need to use this usually, because if you notice something, one of these two objects is actually going to have an x initial other than 0. But what's cool is they'll both have the same x final. And I'll do one of those for an example. So now what I'm going to do is I'm actually going to stop this video and let's just go through and let's actually start looking at and applying these equations to solving some problems. So I'll see you in the next video, guys.